Hi, everybody. Great to see you all back. Hi, Darby. Welcome back again.
Hey, thanks for having me.
How are you doing today?
I'm well, GM. How's everybody here?
Yeah, I think we are seeing a lot of people saying GM, hello, hello, everybody. Crypto Monkey. Yeah, great. So we have Darby with us today. I think you pretty much noticed that he already also we're taking a session about Chainlink data feeds in the last week, and he's here today to talk more about Chainlink VRF, which is really interesting concept to learn. Because if you might be playing games or if you have ever participated in lottery, you know right? Like, how important randomness is really required. Like, how confident were you in the fairness of the outcome, right? So, and also as a gamer, have you ever encountered situations where randomness played a crucial role in your gaming, right? So, how could you build that, fair and trust minimized systems, right? So, this is where Chainlink VRF comes into the picture. So, Darby, uh, just wanted to give the stage to you so that you can go ahead and start the session on Chainlink VRF. Yeah, the floor is yours now.
All right, thank you. GM, everybody. Welcome to the 8th day of the Chainlink Bootcamp. Today, we're going to be handling the Chainlink VRF service and implementing it into a simple game. So we can start out with the presentation here. It looks like it's going. Yeah, should be all right. All right, so in the Chainlink Bootcamp, we're going to be rolling right into this. This is me. You got Darby Martinez. I'm a developer expert with Chainlink Labs. It's a great opportunity. My Twitter is Darby's and LinkedIn. You can find these links here to share this presentation with you guys a little bit later. And you also should have access to this currently as well. So first things first, we're going to go to the pad.riseup. So I'll post this link right here for you guys in the chat, but you may be able to type it in. All right, there's the link for you all. And we're just going to get into a quick presentation here. So Chainlink VRF, it's a verifiable source of randomness. Why is it hard to get randomness with smart contracts? Blockchains are deterministic, as in if you had the function to create random numbers in the code that is live on a public network like Ethereum or any of these EVM compatible networks, you could perfectly predict the outcome. So say you have a lottery or other parameters in a game, you would be able to game that by using the block hashes and times to be able to check your transactions against it. Every blockchain node needs to reach the same result and consensus. So each node would also have a hard time running that random number. Random numbers on chain, the validator nodes or participants could control the entries. As I kind of just explained, that would mean, say you had 1 in 100 chance of getting a loot item, but you were able to send multiple transactions to kind of game that using that logic on chain, you would be able to verify and confirm that you would get that 1 in 100 chance. Enter Chainlink VRF. So Chainlink VRF is a random number generator for smart contracts. It's proven fair and verifiable randomness, and it ensures randomness to your application. This also happens off chain and then gives you a proof of the randomness for your logic on chain. Randomness can be used to provide random numbers for a game, whether you're randomly distributing different characteristics or traits for NFT lines or within games, whether it's loot and other rare items. Along with, you can input randomness for different mechanics within the game. Say your sword has a 33% chance of hitting, then you can tie that in using Chainlink VRF. Or you have a 50-50 chance of hitting, same thing. You could send that information using Chainlink VRF and actually have a provably fair and verifiable source of that randomness to use. So we're, instead of talking about it, we're going to go right hands on into building our own little game. This game is going to be called Runners. We're going to have 2 characters. We're going to mint them ourselves, and those runners are going to run a certain distance based off of the random numbers that we generate. So here we have our different runners. At the first spot, we have the elf, the knight, the orc, and the witch. Each one of these will be able to choose one, and then we're going to pit another against the other one, and we're going to have them use a run function that will take the random number request and create the distance that it goes. We're going to send a few rounds of this game just to show you how to do it, and then we're going to all compete together. And then we have the Chainlink Hackathon's now been announced. Welcome. You can go ahead and apply here. And we have the Chainlink Discord, but I'm going to hop right into the presentation. So on the Rise Up pad, I have preloaded a whole bunch of resources for you. We have a link to our Chainlink Discord. We have all the video sessions on Luma, along with I provided the YouTube link here as well. In this link, we have all of the slides so you can follow along or revisit the slides after the fact, along with these exercises. And then we have the Chainlink Bootcamp 2024 task form. I'm just going to highlight the task for ourselves. So the ones that we're going to be implementing today is our smart contract for our runner's address, and then the VRF ID subscription, which we will create on vrf.chain.link. I'll walk through that with you all as well. Then we have some more resources like faucets. If you do not have testnet link or AVAX, because we're going, yeah, absolutely, I can zoom in. Is that a little bit better for you guys? I hope so. So then we have the task form and these faucets. We're going to be operating on AVAX and Avalanche Fuji. So make sure you have testnet link on Avalanche Fuji and AVAX there, as that's going to be a little bit faster for us. And then I have a hard link for the Chainlink Hackathon Block Magic. So you can go ahead and go there. We're going to start with VRF, learning VRF. We have our references here, and I'm just going to walk through these with you guys really quick. So we have dev.chain.link, product VRF here. So in this, we have the VRF resources. You can start building, you can read the documentation. This will lead to docs.chain.link. And then you have some quick starts here. In the past, you can, well, right now you can go right here, learn how to do a giveaway. You can do a quick demo, a VRF enabled mystery box, pass VRF costs to the end users, a little bit more complex, but very good to learn, especially if you're going to implement this in your own game or you are programmatically minting NFTs. And then we have guides as well. So programmatic subscription, how to get a random number, and then beginner tutorials as well. Another good example of VRF that is out there is we have this case study, which I will take and show. We have the NBA uses Chainlink Oracle Network VRF to power the association's NFT collection. And I will provide this link here in our remix as well. Or not our remix, but our pad. Next, we have subscription, that are supported networks. These parameters are going to be important for us as we go through this. We are looking at the Avalanche Fuji test network. This is the contract address for the link token and the contract address for the VRF coordinator, which sends and receives our request for the random number. We have the key hash, a premium, the max gas limit, the minimum number of confirmations, and this changes per network that you're on. So Polygon Mumbai, for example, has a minimum confirmation of 3 blocks to confirm the random numbers, whereas Fuji has 1. This is why we're going to be using Fuji today. Maximum number of confirmations is 200 and 500. And when I get into the code here, we're going to be able to see that we specify all of these values ourselves. We have VRF best practices, our VRF security considerations. So using request ID to match randomness requests with their fulfillment in order, choosing a safe block confirmation time. That goes back to that last tab that I just had open for you. We do not allow re-requesting or cancellation of randomness. They don't accept bids, bets, or inputs after you have made a randomness request. And then fulfill random words must not revert, along with VRF consumer base in your contract to interact with VRF services. You can see all of these best practices here in this link, and I've provided that at the beginning. And this follows up with more best practice information. So all of this here is at your disposal, and I made sure to give that to you right off the bat. This could be done for other token giveaways. And then we have a bunch of people already joining us here. It looks like between 131 and 52. So we have about 70 to 80 individuals joining us. Welcome. All right. My favorite color, I'm going to go with Darby. My favorite color is green, but then I also like that sunset orange. So I'm going to go ahead and type that as well. Joe's, good color. Welcome, everybody. How's everybody doing today? Hugo, blue like Chainlink. I like that. Kadri, I like how you included the CSS and HTML code for the color block there as well. I'm going to make sure to revisit that. Henrik with the 0 zeros. That's cool. I like you guys. You guys got a sense of humor. All right. So we're just going to rock right into it. So I'm going to include the first step at the bottom of our pad here. And we have MetaMask, Avalanche Fuji. We're going to open up Remix. So open Remix. I'm going to open this in my tab here. And first things first, we're going to go to the deploy and run transactions. We're going to go to our objective provider. I'm going to increase the font here as I speak. Hi, Solange. Welcome.
Hi. Hi, Darby. I came here just to tell you to increase the font, but you are amazing. You already did it. Another point
Yeah.
that you can do, could you see that hide button down in the bottom of your screen, in the middle?
Oh, yeah,
Yes,
absolutely.
amazing. And
Cool.
you are so great.
Hey, you too.
Thank you. Bye.
How's your day going? Bye.
So good.
We'll talk later. All right, cool. All right, so we have this screen. Right now, this was going to be not populated for you, but I'm going to give that code to you in just 1 second. What we're going to do is we want to make sure in the environment, on the 4th tab here, we have deploy and run transactions. Then we go to the environment. We want to make sure to select the injected provider MetaMask. When you connect that, it will pop up your MetaMask to confirm that you're logged in. Mine is, so it already pops there. What we have is then you can show that your account is here. This is my wallet address, runners.sol, and here's the code. So I'm going to go ahead and copy and paste this into the pad as well. Let's do this. Rise up pad. Copy. All right, you're gonna include this. So I'm going back to my remix. I'm copying all of this for you. Going here, and then between the begin and end, I've included the code. You can feel free to copy and paste this into your remix, but do not deploy it yet. There's a step that we need to do upon deployment that we will go over. When we open remix, I'm going to walk through this code for you really quick. So I'm going to get rid of this deploy transactions and walk through it. So line 2, we have pragma solidity 0.8.19. And what that does is it is identifying the version of solidity that we are compiling this contract into. Then we are importing some contracts here. These 3 are the contracts required for the ERC 721 or the NFT contracts. And then these 2 are Chainlink contracts for the VRF coordinator, which is going to receive a request for a random number and then also send us that random number for use in this smart contract. So the contract runners is an ERC 721. It has the ERC 721 URI storage, and then the VRF consumer base V2. It is using counters to count the amount of tokens that we have for our characters. And then it is using strings for a uint 256. So the VRF, this contract has 2 events, which is the request sent and the request fulfilled. And these are sent to the VRF contract or the coordinator contract, allowing us to get a request ID and the number of words and a request ID and a random words. And this will allow us to fulfill our random number request. Then we have our struct, which is basically showing a true value or false, a Boolean value, whether it exists and whether it is fulfilled. And then it is adding random words or random numbers to a array, which is 256, or unsigned integers 256. Then these are getting mapped into a S request, and that is associating the request ID with these 2 values here, the fulfilled and exists. Then we will go into the VRF coordinator information. So if I open this link here, this will open back up the supported networks that I just showed you at the beginning here. And this will allow you that no matter what chain you are operating on or working on, you can have access to it. I'll make sure to increase the size of Remix as well. Is this a little better for you or even more? I do like Arc. I think it's very clean and it removes a lot of clutter. Usually I have a whole bunch of tabs going across the top, and after a certain amount of resource grabbing, I end up getting lost. So Arc helps me get rid of that. Back to the topic. So here we have the VRF coordinator V2 interface marked as coordinator. And here are the values here. So we have the VRF coordinator address, and this is the address on Avalanche Fuji. This is the key hash. And then here are the parameters required. So this has request confirmations 3. If we looked at the Supported networks, it said there was 1 block required, but we have it here on 3. We have a callback gas limit, and we are requesting 1 random number. It says random, or it says number of words, but let's consider that as numbers. Then we have the past request IDs, and these are just variables that will allow us to see our request ID, our last request ID, and our last random words. We'll see that as we deploy this contract on Remix. Then our subscription ID. This is going to be important when we instantiate this contract and deploy it. Then we have these characters and their images. They are stored on IPFS. So just going to go ahead and click it. This is our elf. This is our knight. This is our orc. And this is our witch. Think of it as 0, 1, 2, 3. And that's how we're going to call them later. And when we create our characters for our game as well. So then we have the struct runner, and struct is a custom data type that allows you to store multiple data types. So we have the name, image, our distance, and round. And then it is mapping it and then connecting the runners to a request ID. And then we have the constructor, which both calls the constructor in the ERC 721 contract and the constructor in the VRF consumer base contract. The constructor itself for this contract is requiring a subscription ID to deploy. It is then inputting 2 strings into the ERC 721 constructor, and this is going to be the token name and the token ID, or the token ticker, along with the VRF coordinator, and this VRF coordinator is identified right here as well. Then we are tying the subscription ID to the subscription ID, and we are calling the safe mint function with the message sender address and a character ID of 0. So when we deploy this, we are going to receive the elf. Right on to the first major function of this contract. We have the safe mint function, which is requiring an address for the receiver of this token, and then the number of the character ID, which can be 0 to 3. It is a public function, so anybody can call it. And then what is happening in these 2 lines here is we are saving the character ID without changing it into an auxiliary variable called aux. And then we are checking to make sure that that aux is between 0 and 3. And if it is outside of that, then it is an invalid character ID. Then we have our character image, and then the characters image and the character ID, and this is identifying which character that we have. Our next thing is we're taking, if you notice, we have runner here, and this is this struct. So these variables here, this is going to be the name followed by the image, and then it's set, we are hard coding the set distance at 0 and the round at 0. Then we have our token ID and the token counter, and this counts it up, allowing our contract to know where we are with the creation of characters. And then this here, we are encoding the URI to showcase on our NFT. So then you have the name, the runner's token ID .name, the description is the Chainlink runner, the image, and this leads to the image. And then our attributes, which these are changing. We have distance and we have round, and this is how we update it with distance to string and round to string. Then we have the creating the token URI. where we have a final token URI, and we are encoding this into data application /JSON base 64, followed by URI here. Then we are incrementing our token ID counter, calling the safe mint to, and then token ID, and then we're setting the token ID, token URI here as well. Do we have any questions so far? It looks like we are okay. All right, so then we are on to the run function. And this function is going to be what calls the Chainlink VRF coordinator, while also creating the distance that our character is going to be running. So when we run this function, we are going to be needing the token ID of the token that we're using. It is external, so anybody can run this. And then it returns the request ID, which is for the random number. So we're requiring that this token exists, and that's what this line of code does. And then this here is important. So our request ID equals the coordinator, and it's requesting the random word. So we're calling the request random words function on the VRF coordinator. And then that function itself takes these 5 inputs. We need the key hash, the subscription ID, the request confirmation, the callback gas limit, and the number of words. And all this was verified up here in this. Then we have our S request with the request ID and the request status. So the request that we're calling request status, and we're including the random words, creating the exists true and that it fulfilled false. Then the request ID, we're pushing that into the request ID. Then the last request ID, we're updating. We're emitting the information for the event, for the request ID and the random words. And then we're putting that into the token ID, and we're returning the request ID, which happens up here. Next, we have fulfill random words, which starts with, we are adding the request ID and the random words. And then this is internal, and it overrides the base function within it. So then it's requiring the token ID counter to exist, that you must mint an NFT. And then if the request is not found, this is the check there. This is making sure that the request ID is fulfilled and is true. The random words are here, and the last random words are updating the random words. Then on this, we are manipulating the response from the random words. As it is such a large number, we are essentially dividing it by 10, adding 1, and then multiplying it. So it becomes a little bit easier to deal with and giving us a nice and easy 0 to 100 random number. Then this token ID is changing the run function set to external because it needs to get out to VRF, having it internal as it should only be done within the contract. This is a very good question. I believe so. Solange, would you be able to answer this?
What? Let's see.
So they're saying the run
Yes,
function,
exactly.
the external here.
No, in fact, when we have an external function, it means that we cannot call this function inside another smart contract. And the difference between them, we used to use external to save gas. External is more economic than public. if you have a function that's public, can be run inside or outside. But for us on this content, it doesn't make sense to run the run function inside, so it's external.
Okay, thank you, Solange.
You are welcome.
Now we're back to this. We're recoding the URI and then updating the distance and the round. And we're creating the token URI here as well. Then we have this function, the get request status, which takes the request ID and it returns whether the Boolean has been fulfilled and then the random words. And then these functions are required by Solidity as well. So we have the token URI and burn. Okay, so now that we have this contract here and we post it in here, if you guys go to deploy and run transactions and we try to deploy it, we're going to notice that we want the subscription ID, and we can find that once again in the constructor. So this constructor here is we need this subscription ID. I'm going to walk us through how to receive this subscription ID, connect these two so we can deploy this contract. So the first thing we're going to do is we're going to go to vrf.chain.link, which you can find right here. I'm going to post this at the bottom of the pad. vrf.chain.link. So go ahead and open this, connect your wallet. You want to make sure your MetaMask is on Fuji, that you create a subscription on Fuji. And then at the end, we're going to all share our name and subscription ID. So I'll walk you through this right now. vrf.chain.link. It opens up. You can see that I am already connected, but if you're not, right here, you're going to have a connect wallet button. Once you are connected, then you want to make sure this says Avalanche Fuji. At the top right corner here, Avalanche Fuji, you'll see that I'm already connected, but let's say I'm not. I'm not going to disconnect, but here we're going to create a subscription. We're going to make sure my admin address matches my address. It's the same. And I'm going to create a subscription. It's going to ask me to confirm the transaction and sign this transaction. I'm going to go ahead and do that. Then I'm waiting to receive confirmation. You can open up the Block Explorer to get that information and see that it was a success. So then you close. You can go back to the beginning by hitting home. And then you'll see that my new created subscription ID is 1887. So I'm going to take that. I'm going to take my 1887. I'm going to pull this into there. Go back to the pad. Type my name and include my subscription ID. If you all following along can go ahead and share your subscription ID, that'd be great. Parvin, I see it's asking you to change network to Sepolia. Try confirming that and then changing it back to Fuji itself. Or you can go into your wallet itself, switch your own network to Avalanche Fuji network, and then reload the website. Please go over it again. Can do. All right, so vrf.chain.link. Connect wallet. Make sure you're on Fuji. Create subscription. Click create subscription. Confirm wallet is the same. Create subscription. I'm not going to create it again, but when you click this, it's going to pop up your MetaMask, ask you to confirm the transaction. When you confirm the transaction, then you will wait. It will be confirmed. You go back to the home, you find your subscription here. You click your subscription, you open it up, you copy the subscription ID. Did that help, Godwin? I hope that helped you, Godwin. If not, I'd be happy to go over it again with you. So, good job. All right. Gilbert, 1911. We have Joss in 1906. 1899, George. Taiwo, 1913. Philip, 1900. I like Rack Tim's number. The trip 8s is nice. We got any 7s in the chat? All right. Look at us. We got about 70 people still following along. Fantastic. Then our next step is we're going to be adding funds to our VRF subscription. So then I'm adding these notes here. We have VRF add funds. We're going to click a button called actions. We're going to fund the subscription. Then we're going to give them 10 link, and then we're going to see where we can see our subscription after creating it. So I'm going to open back up here. I'm now in home, Avalanche Fuji, my subscription in my ID here, 1887. Actions, I'm going to fund subscription. I'm going to add 10 link, and I'm going to approve the transaction. And now we can see that my new subscription ID has a balance of 10 link. Let's go ahead and take our subscription ID and go to the task form. I'm going to copy it down at the bottom here. That way you all following along can this looks like extra. Let's get rid of that. Yeah, we still have that there. In the task form. So if you open the task form, for the sake of the workshop, we are using 10 link, but you shouldn't need more than 3. You can always withdraw it after the fact as well. And go to find 08, smart contract runner. But the second one is the VRF ID subscription. And we can paste our subscription ID number here. Make sure you follow along and do this. Tiago, you should be able to find that contract address in your Etherscan or Sepolia scan or the CCIP scan, actually. You should be able to find all that in your prior transactions within your wallet. So you should be able to update that as you see fit. Now, we're pretty much ready to deploy. So I'm going to input this next piece of information for us in the pad. Josh, you may have to select and the new 1965 ID with balance is 0. Make sure that you're within your subscription manager, and I'll show you how that looks like considering I have 2 right here. So, I have a prior one that I did to prepare for this, and this one is that there. Say I open that up and fund it, then that's where the value may have been. You may have accidentally added your funds to this one as well, or your old one as well. But for the sake of this workshop, feel free to add to the newest one. We're going to deploy. So I'm going over to Remix. I'm taking my subscription ID. I'm making sure that since we played around a little bit, I'm making sure that my environment matches what I need it to go to. I have the Avalanche Fuji 43113 up here at the left, and then underneath our ejected provider MetaMask, it is my wallet and my account. And now the deploy tab, the button is showing a bright orange because it is waiting for me to deploy once I have included my subscription ID. I hit deploy. MetaMask opens up. I confirm the transaction, and now I'm waiting for this to deploy. Now, we have this here. We won't be able to do anything yet because there is one more step that we need to do. But first thing we're going to do is we're going to go take a look at our deployed contract and the NFT that we minted in the constructor with the safe mint in OpenSea. So what we're going to do is rise up. Yeah, good job. I jumped too far forward. So Darby, and here's my contract address. Good job, Mike Wang, Josh, Theodoros, Rec Team, Parvin. Who's my friend that was having a hard time with the subscription ID? Was it Godwin? I'm waiting to see you here. Okay. Jason, great job. Henrik, Oxo2, Emil, 1887. All right. It's looking like we're getting a solid amount of contract addresses here. Mayowa, Nolan, Simon, and Carmine. David, fantastic. Way to go, everybody. So now we've deployed a contract that has access to VRF. We're going to take this contract address and we're going to open up the OpenSea testnet. So I'm going to copy and paste this to you guys. All right, Godwin, I got you. So how you get your address is once you deploy the contract by having your subscription ID, you hit this deploy button, you wait for the transaction to go. You'll get a confirmation, like a little green check mark here. And then at your bottom left, you have runners at Ox A. Mine says A32, but this right here is the contract address, and you can copy that contract address by clicking this copy button here. And then just include that in the Rise Up pad. So then we're taking our contract address, remix, copying that, opening up the OpenSea testnet, searching our contract address, and clicking the collection. Here we have our elf shows up. Yay, that's my elf. And I can go and check anybody's in the pad. So I'm going to go open up this link. And here I have, it's not what I wanted to do, but that works. I have Josh's, I have Rec Teams. Everybody's got an elf because in our constructor, we have identified that the character ID is 0. Good job, everybody. Let me just double check, see if Godwin's following. George, these links are links to OpenSea, the testnet OpenSea, which is allowing us to see our NFTs that we minted in the constructor of this contract. All right. So Godwin, when you deploy your contract, you're deploying it with the subscription ID. If I'm remember correctly, you had trouble getting the subscription ID. We can walk through that once again. So go to the VRF subscription. I'm going to walk through this entirely for you. So create subscription, address being the same, address being the same. aux4f, aux4f, create subscription. It creates the subscription. And then when that subscription is created, you can see that subscription ID here. You take that subscription ID, you copy this, 1887. Mine is 1887. You bring it into Remix. You deploy that by including that subscription ID here in the Deploy tab, and you hit Transact. When you hit Transact, it'll ping you for a transaction. I'm going to reject it because I don't need to deploy another contract. And then when that confirms, you will have the contract here at the bottom. You will then take your contract address by copying this here and then including this in the Rise Up pad first. Then you will take that same contract address, open up the OpenSea testnet link, paste that contract address into the search bar, click the collection, and then here you have the collection. From here, you are taking this URL, copying that, and then providing that for the Rise Up pad. We might have a 777 here. We probably do. 777 Demetrios. You got the lucky number right here. All right, I like to see it. Then our next step, we're going to add a consumer to our VRF. This will allow us to use the run function, receive our random numbers, and apply it to the game. So in our vrf.chain.link/Fuji link, you'll open it up and you'll see this here. We are going to click our subscription ID. We're going to add a consumer. we're going to take, we're going to take our contract address that we deployed, copy that contract address, and then go back to our VRF subscription, add a consumer. When we add a consumer, it's going to ask us to confirm the transaction. Check to make sure that this transaction went through. I'm seeing a success here. Go back. So now we can see in my Avalanche Fuji, my subscription for my 1887 subscription, I have one consumer. It is Ox A32, which I can verify is the same as my contract address, Ox A32. Then we are going to run our first transaction. Going to the pad. All right, now we have a new list of tasks for us to do. So on Remix, on the runners, our contract, we're going to expand it. Then we're going to execute the run function with the parameter token ID. We're going to check some blue buttons and double check everything, ideally receiving an output somewhat similar to this. So I'm going to walk through that right now. What we have here is we're going to open up runners. We're going to go down. We're going to see all of our functions and parameters within the contract. We're going to find our run function. We're going to open it up and get our token ID 0. Then we transact running the run function. We can confirm it. And that wait for confirmation. That confirmation we can see here. So now what do? We check the last request ID and we can see this value here. If we copy this value, this response, and we paste it into the S request, and we call it, we will see an output that says true and true. This output is the same as what's happening up here with the request status, and it's pulling this fulfilled and exists, and it's showing us that both of these happened and that they are true. Then the next thing is we're going to find runners. I'm going to open this up so it doesn't get so confusing. Runners, and we're going to take our parameter as 0 because our first token ID and our first runner. Rodrigo, possibly. So did you add your contract to be a consumer in your VRF subscription? So you would take this contract address, copy it, go into your VRF subscription, and you want to make sure that the consumers here, that is there. So you would add a consumer, paste your contract address into it, and then add the consumer. That is making your contract, your runner's contract, able to call this subscription to request Chainlink. If you see, mine has run the run function, resulting in a random number and resulting in distance, and it costs 0.04 or so link to do so. Please explain the request ID. Absolutely. So, all right, last request ID. This is showing that the last time we ran the ran function and we sent the random number, that we get this back. So this is proof of the last request ID. We're copying this value here and we're putting it into the S request to verify. When it's in the S request, this will populate with fulfilled is true and it exists as true, which means that we received our random numbers. Then the next step would be to go to our runners, include our token 0, and we're calling it. And we should get a distance or a response similar to this. So it's got our name of the elf, our image, which is the IPFS link, our distance. Mine was 50, and that was a random number roll. So I randomly drew a distance of 50 meters or yards or whatever side of the ocean you live on, whether, yeah, United States. Let's go meters. Most of you are probably abroad. And then this is the first round here. So what we're going to do is take a look at our testnet runner, check out the levels, and we'll see that it's got distance 0 and distance 0. If I refresh, it's got distance 0 and round 0. So what we need to do to refresh this so we can see this on OpenSea is in the top right corner, we have 3 dots for more. We're going to click it and then refresh metadata. We're going to give this a second to think and respond, and then I'm going to refresh the page. If I go down now and open up the levels, we'll see that my character ran 50 meters. And this is the first round. Rodrigo, are you still having trouble running the run function? Going back to the pad. I'm going to give some new. Yes, you just ran 10 meters shorter than my character did, but we're actually going to see that right now. So my name is Darby. My token ID is 0. My distance was 50, and this is round 1. If everybody, what we're doing here is we're going to identify who ran the furthest and to see if anybody got 100 or more, which shouldn't happen, but see who got 100 and see of the 70 people following along here today, if who the winner is. All right, so we have Josh has 100, so he ran the furthest so far. Then we got Rock Team. Bruno, I'm sorry, man, you only 20. Leon 30, Demetris 80, but you still got the random number draw on the OpenSea testnet page with 777. So I consider you very lucky, man. You got Parvin with 100. Albin's got 100 as well. Jeremias has 100. All right. Josh got 100. Yeah, I see that. David, I got you. How do you check the distance? One second. Let me get rid of these from How do I check the distance? So we're going to go to Remix. You can go to Runners. Right here, Runners. Type in parameter 0. Call that, and you're going to see an output that looks like this. String name elf, string image with the IPFS link, distance 50, round 1. Thanks for helping out, Iculus. Small distinction is we're calling the at the beginning, we're running the runners function and we're using token ID 0 to call the runners function on our first token. Yes, but to see the distance, we are just checking the view of the runners and the response here, which is the difference between the blue button and the orange button. One is view, one is write, and this is changing and calling these functions. So you have the run function, and then we have a view here, which is our runners. Now, next step, what if we want to add another runner? So this can be a little tricky, but not for us because we're learning and growing very fast. We've got another runner. So we're creating another player or NFT in our collection. What we're going to be doing is running the SafeMint function. We're including the information for our wallet, and then we're choosing a new character from 0 to 3. Then when we run, we're going to run the run function again, but this time with the token ID of 1. And then we're going to be sharing with the pad our name, our next token ID, the distance, and then round 1. So let's walk through that on Remix. Demetrios, it's probably because you ran the run function. Right now, you only have one character. So if you ran the run function a second time, it probably checked and then verified that it is going into round 2 as all the other runners have run once. So since you had one and you ran a second time, his second run is happening in round two. We're going to say the SafeMint function. I'm going to collapse run and open the SafeMint function. So we are looking for 2 parameters to include here. We have our wallet address. So I'm just going to take this from my MetaMask, my aux4 F808, pasting that there. And then character ID. Now I can choose which one I want. And I think a elf versus an orc is a good battle. I used to like Lord of the Rings, so I'm going to go with 2 because I want my second character to be an orc. Going to transact, confirm the transaction, and we're waiting for this to populate. Now that it exists, I can go to runners, call, no, that's not it. I apologize. I'm going to run my token ID 1, as in this is the second character in my game running. I'm going to hit transact, confirm the transaction. Confirm my transaction. wait for it to respond. Then I'm going to open runners 1. See that my orc has a distance of 0, but let's see if this changed. It did. I'm going to take this, place this in. So when I say this, I'm going to take the result from clicking last request ID, take the result here, copy it into S requests to verify that both are true. And then I'm going to my runners and updating the runners, and I see that it has run 90. So out of my character, my 2 characters, my elf has run 50 and my orc has run 90. So I'm just going to go input this into the pad, and I see some others are already doing that. Let's get that out of the way for us. Darby, token ID 1, 90, round 1. So do we have any hundreds here? You're just extra lucky, Bruno. Henrik, it's okay. You'll get them next round. It's good, dude. You're gonna land 2 100s right off the rip. Gilbert, you got 60. Good job. We've got As Andrew with 100 meters. All right, we got EK with 100 as well. We have David with 100. Jason, you and I were close. Albin's rocking a cool 130, but he's on round 2, so that makes sense. All right, we got some 20s. Now, really what we're doing is we're following up with Godwin. Nice. You're in the. Now what we're going to do is we're going to complete the round 2. But first thing we're going to do is go double check our OpenSea link. To take a look at our characters. So when I open my orc and I hit levels, you'll see that this isn't populated. Once again, Zanuli, if yes. Do you have access to the faucet? It should be at the top of our pad. So you can receive Fuji or Avalanche in the pad. But then if that becomes a problem, I could always send you a little bit of Avalanche from myself as well. Back to this, we have the orc. We see our distance is not populated, so we're just going to go to the triple dots up in the top right corner and refresh the metadata. Give that a second to think, refresh the page. And then you can see that it updated 90 of 90 and that it is round 1. Dan, looking for your comment, Dan. Thanks, Barath. All right. So then the next thing, we're going to go back to our remix and we're going to run a second round. So this one is fairly simple. We have all the pieces to the puzzle already populated. So what we need to do is go to our run function, go to our token ID, make it 0 again, because I want to update It's probably because you're two different characters. So Puff's chain and Tiago. Probably because in round one, you're two different characters. One ran 70 and the other ran 80. So it's showing that the higher is 50. And then the lower one is, so if it's saying that you ran, it's showing 30 out of 40. One of your characters ran 30 meters and the other character ran 40 meters in that round. So it's showing one of them is the winner. I'm going to run this transaction with token ID 0 as I want to make my elf run again. I'm going to transact and confirm the transaction. Yeah, that's right, Tiago. So it's saying it's kind of showcasing both side by side. So when you look at the orc, it's showing that you ran 30, but the total top value of the other one was 40. So it's showing the discrepancy between the two. When I click last request ID, it changes. I can verify that I got the random number by hitting the S request, and this stays true and true. And then I'm going to go back to my runner 0, which is my elf. See? And since I ran 50 last time and my distance is now showing 120, my elf now ran a total distance of positive 70. Then I'm going to go ahead and run the token ID 1 again to make my orc run again. Confirm this transaction. Let it go, let it go. I get the confirmation green. Mubashira. Go to OpenSea. In the top right corner, you should see a 3 buttons here, or 3 periods here for a button called More. Click that and refresh your metadata. Did that help you, Mubashir? And then you can see that my orc ran for 40, this new distance, doing 130 total. So in the pad, I have in the pad, I have included this. So we're executing the run function with token ID 0 and then doing it again with token ID 1 to get the second round. All right. David's got some good number there with the 180. Parvin, his elf, really ran the distance. Do we have any 200s? I'd be happy to walk through again, Mubashira, where you are and make sure that you can follow along here in a second. Let me let other people update here, then I'll jump back to where you are and help you out. Absolutely. Mubashira. Let's go to your OpenSea link. You have 3 tokens. So your elf is going to be what you started. Let's take a look at the details here. So that was 18 minutes ago. Your witch was 12 minutes ago. And your knight was 3 minutes ago. All right, so you probably have a issue going to the second round because you have 3 characters here. So in your remix to catch up, what you're going to want to do is, since your elf has a level and it already ran, and your witch has a level and it says it hasn't, but let me update the metadata to double check. Refreshed levels. Yeah. All right. So I know where you are in the process. So go to your remix, go to your run function, go to token ID 1, or in your run function here. Let's collapse this so it's a little bit easier. All right. So run function, your token ID, you're going to want to select 1 and then hit transact. When you hit transact, it's going to verify, and then that character is going to run. Then, since you have 3 characters to go to round 2, you're going to need to make sure all 3 characters go for a run. So what you're going to then do is then go back to this function, call it for 2, and then transact here as well. So then you're going to have character 1 going for a run, character 2 will go for a run, then character 3 will go for a run, allowing that to complete round 1. And then from there, you're going to go character 0, run, character 1, run, and character 2, run again. And that will allow you to go on to round 2. Let me know if you still have a problem after that, Mubashira. When you run the second round with the orc, the second runner, you get a gas estimation. Let's go double check. So, rise up pad, max. Bartholomew. Seems like a good question here. I have a problem because my fulfilled flag is false. I have no idea how to repair it because I am repeating the steps after you. All right. Let's pull that up. So what you're seeing is in this, when you click your last request ID, you're getting this, and then you're copy and pasting that here, and you're receiving a false. Which one? Is it the fulfilled? Fulfilled flag is false. Okay. So that means your VRF coordinator did not respond with the random numbers. So there may be a problem with your VRF subscription and then also the consumer of the VRF subscription. So we're going to go double check that to make sure that in your VRF subscription, you have link as a balance and that your contract is the consumer for your VRF subscription. Any character run 200. Nobody's character ran 200, but let's continue to problem solve. Who else? All right. Mubashira has done the transactions, so now you should be able to show a second round. If you want to populate that in the pad so I can take a look, that'd be fantastic. And then all right, Tiago had false unfulfilled as well, called again and turned true. It does take a few blocks to confirm the random number. So if you hit the S request button for the true values in Remix here too early, it may not have responded. So if you click it again, that may update the same way that Tiago's did. All right, Nick's on the pad. Cool. Now I can follow up with that. Rise up, find NIX. Let's go to your OpenSea. This way I can take a look. All right, so you have an elf, an orc, and an orc. So you got 2 orcs there. You got your elf. It ran a total distance of 90. Your orc, it's saying your second orc hasn't run. Let's just refresh the metadata to double check. It has. All right, that's on me. So it has run, and your second orc ran a distance of 70. And then your third orc, which would be token ID 2, has a distance of 40. All right, you have all those going. So that's working. You are on, it says round 2 is working at this moment, Maxon. So you're probably running through these transactions as we speak. Do you have any further questions, Maxon? Got you. All right, Maxon, cool. So you didn't safe mint the second time. Great. Any other questions on how to do this? That way I can help you out and run through it with you. Josh Ponds, that can be a little tricky. So you have 2 contracts with the same address. That can happen very rarely with I believe it's the knots that can impact contract address creations. I don't know the specifics on the technical and would invite Solange to come clarify this question if she is willing.
Yes, sorry, I was not paying attention. What's the question?
Yeah, so Josh Pons here posted a question saying, I understand these 2 contracts have the same address. And the comment before that was, when I paste the contract address on the OpenSea search box, he gets 2 search results. The first is the collection with the elves and orcs, and the second is with the seeds you made in session 6. So that probably has to do with the nonce.
Yes, exactly. This is related to one collection, it's on Avalanche Fuji. The other collection probably is in Sepolia. And when we have the same nonce in different chains, this can happen to have the same address of the smart contract. It is interesting. Like if you use the same nonce, doing the same thing, like do a transfer, create a smart contract, call some smart contract in the same sequence in different chains, probably you can get the same results.
Okay, great. Yeah. Does that answer your question, Josh? Let's check the contract. Yeah, that makes sense. So your Flower Bootcamp one is on Sepolia.
Exactly.
And if I copy and paste the same thing there, I get your runners collection as well. And this is on Fuji. So you just have an overlap of your two wallet address or your contracts here defined by the nonces. It's a rare thing, but it happens.
Yeah.
Thanks, Solange.
You're welcome.
S request is inherited, but you should be able to see it. S request right here in the mapping where we're taking the request status with the bool fulfilled, bool exists, and then an array of our random words. And then we're associating that request ID with the request status. And that's what we're showing when we click this S request. We're showing this request status and these two values here. Let's see, any other questions? Waza, yeah, I'd be happy to help you. Where you at? Let's see, Waza. You have 5 things pending in your MetaMask. All right, so you can open MetaMask. I usually, when that happens to me, it's like batch transactions, and maybe it's waiting for one down here to go through before you can even confirm any of those, but it's not giving you a prompt to do that. If it's pending, sometimes I'll just reject all of them down the line and then reset, like close out and open it back up, and then try the transaction again. And usually that works for me. I got stuck yesterday doing the exact same thing. Let me know if that helps you, Waza. Sweet, Jan, way to go. Way to go. All right. So let's go back to the pad and take a look at everybody's characters and see if who got the furthest distance and then which tokens that you chose. So here we have Mubashira. He's got an elf that ran 100 and a witch that ran 90, but it said is round 1. Pretty sure I double checked that earlier. Let's go ahead and do that again. Mubashira. Go to your collection. You have your 3. So go ahead and run. Yeah. To get to round 2, Mubashira, since you have an extra character, you're going to want to run the run function again, but with token. Okay, you did. All right. Token 2 to get there. And now you're on round 1 at the end of your 3 characters. So then let's go back to your elf. Refresh your metadata. Double check it. You're on round 2 there. Good stuff. We have the elf or the witch here. Going to refresh this. You're on round 2. Your elf or your witch here needs to run. So go to run the transaction with token ID 1 for your witch to add a new distance for the second round. And then same for the knight, which would be token ID 2. You can run the run method for token ID 0, but receive an error with token ID 1. Let's take a look at your OpenSea and see if we can find anything. So Alexander, I'm assuming this one's you. All right, I can directly identify your problem here. So you have one token here. So when you try to run token ID 1, you're calling a second token, which you don't have. So to fix this, you're going to go to Remix. You're going to go to this function here, SafeMint. You're going to include your wallet address. So, and you can get that either by going to the top here in the account and copying and pasting from this clipboard and including it here, or you can take it directly from your MetaMask, copy that wallet address here, and paste that within there. And then you're going to choose a character ID. It's going to be 0 through 3 are your choices. 0 is going to be another elf. 2 is going to be, or 1's going to be a knight. 2 is going to be an orc. And then 3 is going to be the witch. And then when you transact this, you're going to create a second character. And that second character will have token ID 1, allowing you to do the run function for token ID. With Remix and OpenSea, George, why you can get different results is sometimes, for example, this may not have updated. So what you would do is you go to the 3 dots in the top right corner, click more, and refresh the metadata. When you refresh the metadata, you're giving the command to OpenSea to recheck everything, and then it refreshes. So then you should see the values in your levels change to further reflect what's happening in Remix. Good job, Mubashira. If you want to include the distance of all 3 of your characters in the pad, I'd love to see it. Can I create another function that runs all the tokens? Is there an example of that? They're not in this workshop, but if you wanted to take a little learning opportunity and try and implement that, you would essentially be running the run function for token ID 0, 1, and 2, or 0 and 1 at the same time. So you can run a transaction that will bunch both of those together, but you may have to update the contract to do that. So if you want to do a little learning opportunity and create a function like run all and then put that together, that could be something you could do on your own time. But for the sake of the this workshop, we're not going to implement that.
Hey, Darby, what
Yes.
about to create another smart contract that call this more than once? Maybe this can be a solution.
Yeah, you could do that, correct?
Yeah, exactly. So another idea is you have this smart contract done, it's good. Create another that can call this in a different way, like using a loop, some of them, to call to all the characters.
Yeah. Thanks, Solange. Godwin. All right, so transact to runner SafeMint errored, big error encoding arguments, error invalid big numbers string value 0 through 3. So Godwin, did you by chance, maybe I misrepresented, did you by chance include the 0 minus 3 here in your transact for it? I was kind of showing that as an example of you can choose to have it as a character ID 0, character ID 1, character ID 2, or character ID 3. If you had the 0.3 or 0-3, it's going to trip up at this checker right here, because what is happening is it is looking for a character between 0 and 3. Anything outside of those given will result in that error. Does that answer your question, Godwin? Cool. All right, sweet.
So let's come back here a bit more, because this is interesting, about examples how to create a contract calling another one. We are doing this since the session number 3, because when we did the token shop is calling the mint function inside the token. Another yesterday, for example, when you did, not yesterday, yes, it was yesterday, when we did the cross chain part, that including we did it this in different ways, because in the cross chain NFT, first of all we created the NFT. Then the second contract was the destination minter. The destination minter call the NFT. So it's the same. We have a smart contract calling another. So you already know how to do that. And I think we are good, Darby. I know that you are only solving some doubts, but I'm so happy with this session. We have amazing sessions, like not too many doubts, not too many problems. Like our students was really coding with you, and this was really amazing.
Thank you. Fantastic. Yeah, it's cool to see everybody do this at the same time, like with us. Like Devel, one of his characters ran 200, which means that he rolled a 100 both times, which is pretty cool.
A special prize to him.
Yeah. Oh, yeah, and then the other thing is to make sure that we don't forget is take your contract address from here. Make sure you add your contract address for your runners in the Chainlink Bootcamp task form. That is a step that I did not do with you guys, but let's make sure that you both have your subscription ID and your contract address here for your runners. That way you can confirm your task form.
I like this question. In fact, any person can create a new runner inside your contract. So if Darby would like to create a runner inside the contract of other person, he can do that. And in the same way, you can run the run function, because we are not using the only owner on that. In fact, I'm not using the only owner on this contract. I can remove that.
Let's go to it.
Yeah. No, yeah, it's not here. No, we are not using that. But this is the point, because we are not using only owner. Anyone can use this contract for another person can use your content. And this is like a future project that I'm creating. I didn't finish, but it's something that if everyone call the same content, we must have the request IDs one by one. So we have more time to have the answer. I have another idea. How can we do this together, but have the result in the same way? I'd like to create like a master runner. Imagine that each of you are a runner and you have your own smart content. Then you are subscribing to some marathons, something like that, with using the address of your content, and then we can monitor that. This is like my second phase of the runners. This will be the future.
I like that.
Yeah.
And then we can have a real marathon with everybody.
Exactly. Yes, we can do that. And yes, the NFT runner address is the deployed contract address. Remember that the runners, it's a collection. Inside this collection, we have a lot of runners. No, you can't, because we didn't prepare to do that. Mayan?
Runner gels, Jan. Cool.
So I think we are done today.
All right. Well, I guess, yeah.
Let's see that. It's hard to know like which transaction are you doing. Are you minting a character? Are you deploying the contract? Are you running the run function? We would like to know which function are you running now. Godwin. So how was for you, Darby? Did you enjoy this session?
Absolutely. Once again, thanks for the opportunity. I feel like every time that I do this, I get a little bit better and I identify like little things that I can improve on. So this has been a very cool experience. And once again, thanks for the opportunity. But it's cool going from 3-ish years ago being a student in these smart contract boot camps and them being the very beginning of lines of code that I even wrote. And this started like a lifelong passion and a career as I move into the future of a line of work that I didn't know that I loved until I found this. And then, not to mention, learning more about how smart contracts interact with each other and then bringing real value and data on chain using Chainlink services is really like it's such an eye-opening thing because every time I see it, whether it's random numbers or data points or with functions and then cross-chain CCIP stuff, all of that like really excites me. And I can see how that's going to be used in so many things and contracts and like social contracts that are broken that to help fix it and bring that transparency. So it's a very cool opportunity. And I thank you very much for the opportunity. And I look forward to the future. Really, like it's just fantastic. So thanks again.
Yeah, I'm so proud of you, Dad, and your history is so inspiring, I think, to all of our students now. And let's only finish the question. Are you at your screen again? And like Godwin told us that the problem is with the run function. So Godwin, probably you didn't add the consumer inside the VRF. This is the only way. When you have problems with this, is because you didn't that. So, Darby, could you show how to copy the address of your content and add the consumer again?
100%. So we have our deployed contract, the runners, and then the contract address. I'm going to copy this right here. Then I'm going to our VRF subscription. In the VRF subscription, you'll see that, let's say I'm going to the home. We'll see that I have my 1887, which is the one that I use to deploy the contract. Here we have my contract is listed as a consumer, but if yours says add consumer right here in the middle, you're going to hit add consumer. You're going to paste your contract address there and confirm the transaction. It's going to ask you to confirm the transaction. Mine already exists there, so I'm not going to. Did that help you, Godwin?
Exactly. And W, we have a question for you now.
So I was a political science major back in college, and then pre-pandemic, I was living in China. Then the pandemic happened, and I was actually home on Chinese New Year, which locked me in America, but all of my funds and everything was overseas in China. I started leveraging crypto to get it back, as wire transfers took far too long and there was a large fee associated with it. And then when my livelihood was required around what was going on here, I decided to learn more about it. Once I was learning more about it, I wanted to create a little bit of like tech literacy and like code literacy, understanding that these are public networks and that I should be able to understand the digital agreements that I'm operating underneath. And I very quickly came to the Oracle problem. And at that point in time, it was about 3.5 years ago, there was a lack of information on how to bring real world data on chain, as like Chainlink had just hit mainnet. It was very, very new. Like the idea and what they were doing was very, very much there, but the resources to learn was like very much budding at the same time. And while I was in that rabbit hole, I learned about a hybrid smart contract bootcamp in a summer of 2020 and then again in 2021, followed by I went to Ethereum Denver and there was a hybrid smart contract bootcamp at ETH Denver in 2021 as well. So then I joined those, and at the time I had a hard time setting up my computer. I didn't really understand what I didn't know, and I didn't really know how to dig deeper into it because it was all so new to me. And I kind of started there with Solidity, where many traditional developers would say maybe you should start somewhere else and learn and then grow into Solidity. But I kind of kept my head down in Solidity and then smart contracts and then real world data for a period of time. And then since then, I've fleshed out a more holistic view. Recently, been building more of a front end capability into a back end capability into full stack, with my emphasis being Solidity and smart contracts as like kind of a specialization, so to speak. Now that has added, it's been 4 years or so, and I'm starting to get a little bit more competent, loving the process, and just that's kind of how I started. So I can't say that I started as a traditional dev. I did start with Solidity. And then as I learned and grew, I understood that there was a lot of things underneath the hood and a lot of knowledge to learn from a more traditional background to get me to a point that I'm at now. I hope that
Yeah.
answered the question. It's a long story.
No, it's amazing. But when the people asked me about that, I used to say that if you don't know how to code, start with Solidity directly. I used to say the same. I have one question here that is interesting. Um, if you'd like to have another image, or if you'd like to use a photo, and I'm thinking this now. So if you like to use some photo, you must have this uploaded in a place. Can be a centralized, it can be a Google Cloud or can be an IPFS. Like for us, we have the images on IPFS on my account on Pinata, and they are over there. So you must have the images in some place, and you could add these images in a smart contract, like passing the URL of the image. This can be an option.
I think that answered the question, and we are like on time. So thanks Darby and Solange for the wonderful session again. Great to see like a lot of people did their first VRF subscription as well and deployed the contracts as well. So yes, guys, there are some people asking questions about whether we have a session tomorrow. Yes, we do have day 9. We are going to learn more about how to access off-chain data using Chainlink functions. In the earlier classes, we were learning a lot about how to fetch market price, token prices from Chainlink price feeds. But what if you want to bring weather data, sports data, everything into your smart contracts, right? Whether you have your own endpoint or like database where you are storing the data, where it can have an endpoint, then if you wanted to bring the data onto smart contracts, so that's where how that's what we're gonna learn tomorrow. So make sure that you are be here again at 8 p.m. if you are from India, or 10:30 p.m. 10:30 a.m. ET. So yeah, tomorrow we're going to have another wonderful session for sure. And yeah, if you want to explore more about Chainlink VRF, I think Darby already had listed all the resources on the Padrise sheet. Go ahead and start learning things. And if you face any problems, you know where to post those queries, Discord and Stack Overflow, right? So yes, so do join the
And
Discord, follow YouTube channel. Yeah,
look at this, I have the t-shirt.
yeah, cool. That looks good.
Yes, and Javier is in the chat. Javier did made this t-shirt for an event. I think it was an event on Chile in Santiago, and we didn't again. Javier, we must do this again and use the other characters. This is really amazing. And by the way, like Barat said, tomorrow, let's give you a bit more of information for you. Tomorrow we are deal with the weather. Okay, our functions is related to the weather. So I look forward to see you tomorrow. And bye, everyone.
Thank you,
See you
friends.
guys tomorrow.
Thanks for joining me today. Have a good day, guys.